Hello, everybody. GM, hope you're all having a great day. My name is Yasin, and we're in for the third workshop of the Educate series on the topic of Phat contract introduction and Schrodinger's NFT concept. We have Joshua Waller today, who's going to walk us through an amazing presentation, which I will invite on stage in a tiny little bit. But yeah, do make sure to sound off in chat. Tell me where you all from. Really looking forward to this session, and hopefully you all get to enjoy an amazing one as well. Let me just quickly get Joshua on stage so he can get ready. Well, in the meantime, I can share a couple of links with you, and as always, remind you that unlike all the other Educate series, this one is a dedicated one. It's a bit different, as in we have a dedicated bounty associated with it. The information about that bounty and what you can do with it, also, hi Joshua, and welcome to the stage, you can find in our hacker pack. The hacker pack is the information you can find all the important bits for this Educate series. You can find recordings of our previous events, the previous topics, as well as the slides. So the slides from this one will also be added. In addition, for those of you that are still looking forward to finding teams or like-minded people to build alongside with, please make sure to fill out this form and share a bit more about who you are, what your background is, and what is your tech stack, the things that you're used to work with, and the things that you're looking forward to engage with. And ideally, once you have submitted, you will be able to then have a look and browse through our gallery of people that have already filled this one out. And so you can find profiles of people that match the skill set that you would like to find complementary and build something. So these are the most important things from my side. And now we have Joshua here to start off with Phat contracts introduction and workshops. Hey, Joshua.
Hello. Hi, everybody. My name is Joshua. I'm the Director of Tech Evangelism at Phala Network. Happy to be here. I'm going to kind of go over Phat contracts, the core concepts here. And then as I'm introducing these, the Phat contract core concepts, I'm going to also introduce like a new direction that we are going with what we call AI agent contracts. But talking about the core concepts of the Phat contract will lead into why they are so important to where we're at with the AI agent contracts that are coming up. And then I'll show a little demo of how to build one of these agent contracts with the Apollon SDK so that you could upload your files to IPFS through the SDK from Apollon, and then be able to then interact with the LLM model from OpenAI's API. So I'll show that, and then I'll show the Schrodinger's NFT example as well. Is there anything else? Okay, cool. I'll start.
You've not shared your screen yet. That's okay. One thing. Yeah.
All right, awesome. So I did my little intro just previously, but yes, I'm Joshua, Director of Tech Evangelism at Phala Network. Kind of the topic today is from Phat contract to AI agent contract. And here's some of the socials like Farcaster, Lens, X, whichever. You can also follow Phala Network at Phala Network for X as well. We've just recently updated our docs. You can check out the link here. So I'll leave this little QR code here so you can go through the docs and see some of the new updates. We have a lot of placeholders with some of the concepts that I'll introduce later on in the talk whenever I get to the AI agent contract piece. So I'll just let this sit here for a second for anybody that needs to use it.
We will have a copy of the slides in the hacker pack as well. So people that missed it right now, don't worry about it. You will be able to scan this at your own time afterwards as well.
Okay, perfect. And this is our Discord link, a little QR code here. Just join the Discord if you have any questions about what Phala is building with AI and Web3 and what to expect. So I did bring this up a little bit earlier, but I'm going to do a quick little overview of Phala's Phat contract and how the core concepts, the core features that led to the AI agent contract. I'll then go into a high-level overview of what the core concepts and the components that make up the AI agent contract. and then I'll show a short demo of a subset of the components, in this case called the agent script. But I'll show how you can use Apollon's SDK to publish your agent script to IPFS, and then use that IPFS. It'll be able to then serve your agent that you have deployed, your single agent in this case, so that you can serve it through our gateway and be able to interact with it with GET and POST request. So let's get started with like some of the core features of Phat contract and how it's kind of paved the way as well. So when we first set out Phat contract, our idea was we wanted to take on-chain applications for smart contracts and enhance them significantly by adding a new connectivity where you could connect to any Web 2 or Web 3 API, so that you could bring that information on-chain in a verifiable way. We called this concept the off-chain rollup in this case. So you would deploy your Phat contract similar to the Schrodinger's NFT. If you've seen it in the Apollon dashboard, in the computing part, you would deploy that Phat contract onto Phala. And then with our off-chain rollup, we would be able to then connect to, on this side, the on-chain piece. So the EVM or the Ink smart contract blockchain, and have an anchor there so that we can request for information to be brought from off-chain, in this case, from the on-chain smart contract. And the off-chain Phat contract would then be able to fulfill that request, go find this information, retrieve it, process on it, and then bring it back on-chain in a verifiable way through our like a signature scheme to verify that this is actually the Phat contract that brought this information in, and we verify it on the anchor end of the on-chain smart contract. But this was like a key piece of what we wanted to do. We wanted to enhance smart contracts. So the idea was having like omni-chain compatible, be able to connect to any EVM chain, any substrate chain, and any other blockchains that are available that we would like to set up an anchor on. And then having that internet connectivity. So being able to retrieve data from Web 2 APIs, Web 3 APIs, and then build these more data-driven smart contracts so that you can kind of take this data and let it drive your business logic, instead of just only being able to use what's available to you on chain in this case. And then being able to also perform some complex logic on the programs that you're building. So say, for an example, in our docs, we have a connection to the graph, right? You connect to an indexer, your subgraph, and then you're able to then take data from this subgraph based on some queries that you created, get this information about an account, and then generate a trust score. So you're able to compute all that logic in the Phat contract, and then be able to then put that back and post it back on chain for anybody that's for any smart contract that's requesting for this type of trust score. So being able to perform this complex logic, and then the best piece of being verifiable, having this verifiable computation in this case, so that you can ensure that the data that you're retrieving from your off-chain Phat contract from your on-chain smart contract is able to be verified in this case, so that you know that the information is secure and trustworthy from our implementation in this case. So just to give a high-level overview of how this looks like as well, like in the first one, but a little more descriptive, is the EVM chain is here on this left side. You have like a push message on here so that the users can request for some off-chain data. The Phat contract here listens for this action queue to be updated, polling for the latest info. So in this case, this is like an example with the Lens protocol. So it listens for a request. A new request is requested for information from Lens API. The Phat contract grabs that information. The information is then retrieved from the Phat contract and then processed, and then a response is sent back on chain through the on message receive. And this is just kind of like explanation, like a high level explanation of how this off-chain rollup works with this diagram. So now that we have like a idea of like Phat contract and how we are bringing this off-chain data on chain, now I want to introduce you the direction that we're moving towards, which is the AI agent contract. And the AI agent contract actually is actually an upgrade of the Phat contract. So the Phat contract doesn't go away. It just goes away in name, but it becomes the AI agent contract with a lot more enhancements to be able to create these AI agents, so that we can then start building these intelligent applications for different Web3 services. So since I was talking about the core features in the Phat contract, the AI agent contract kind of takes it a step further, and it also removes the need to deploy your contract on chain on Phala Network, but instead be able to publish your agent scripts, in this case to like IPFS, and then serve it through a gateway that executes in a VM on Phala Network. But I'll get into that detail whenever I get to the slides, so that you can visualize the diagram. So just to give you an introduction, the AI agent contract is made up of two components. Right now, some of this is still in development as we are building out the first product, which is like the experimental product called Agent Wars. If you've been following our social media, you might have seen some of the tweets about this, or any posts out there talking about Agent Wars. But this is the concept that we are implementing first, so that we can then create both of these components. But the first component that is available right now in a limited fashion is the agent script. So the first component of the AI agent contract is the agent script, which you create your prompts for your like system prompt for the agent, and be able to then write in the same write in TypeScript or JavaScript, whichever, your business logic, and be able to then like set up some retrievals so that you can bring in some data from off chain through some HTTP requests, and then you can process on that data and then feed it to your agent so that it can make informed decisions based on however you customize it in this case. So we have two templates here that I'll show later to be able to get started on this. The other part is the agent DAO. So the agent DAO will be an on-chain smart contract for right now. We'll target the EVM chains at first, but any EVM chain will be able to deploy like a agent DAO that will ultimately regulate these agent scripts. So you'll have a way to split access keys so that users can buy keys and have like an access control feature to interact with your agents. You will also have like a default tokenomic that we're working on right now, but also the ability to customize your tokenomics. And then that would incentivize like any kind of like ownership of this agent in whichever customized ways you would like. And then obviously like setting up the market so that you can buy and sell keys to access your agent. So a little diagram to kind of show like how this looks like. This is like the EVM chain in this case. Here's the agent DAO. And this would be regulating the agent script, which has like the reasoning prompts, execution prompts, and then you can do some like optional implementations that's not supported just yet, but for cross-agent communication, because that's going to be in our roadmap moving forward as well, so that you can build these like multi-agent systems. The thing that is available today in a limited fashion would be the agent script. So you would publish your agent script to off-chain storage. You have your reasoning prompts and execution prompts. Right now, the cross-agent communication is not implemented yet, but this would then be served through a gateway, and this gateway then allows for this this agent script to be then executed in an agent VM, which is, if some of you are familiar with Phala, there's like this concept of side VM. I won't go into the details about this, but it's just a long-living virtual machine so that you can execute your script and communicate through GET and POST requests. So you can make HTTP requests to get data source APIs. So you can bring in data for your agent, connect to different LLMs. So like in the example I'll show today, I'll be connecting to OpenAI. And then you could have your cross-agent communication, which will be supported in the future through the Agent Protocol API standard. So I'll go into the demo. I'll show like kind of like the screenshots of what I did, and then I'll also like exit out and then show you kind of like the repo of how you're able to like use Apollon's SDK to upload your agent scripts to IPFS. So if you want to check out the repo and do that today, you can do that in minutes. You can just scan this QR code, check out the repo, just follow the README. If there's anything that you see that is potentially an issue, feel free to log an issue and I'll fix it as quick as possible. But so I was speaking about this like agent script. So in the repo, I set up a script so that I could publish this agent script. So it's a compiled JS code that is compiled with our like a Phala function CLI tool, and I published that here, so you can see like these different index.js files here in my bucket that I created for the demo. And what I'll do is then take this like CID, serve it through our gateway, and then add some secrets to it so that I can like add like my OpenAI API key and be able to then call my agent. And whenever I would call my agent, it would look something like this. So in this one, it's like the agents.phala.network/IPFS, my CID, and then I define my key, which is the ability to access my secret vault so I can get my API key and be able to then make a call to my OpenAI agent that I just deployed. And here I asked, when did humans land on the moon? And it replied with humans first, land on the moon, July 20th, 1969, Apollo 11 mission. But this is just like a basic, the template is like very basic, it's very minimal. It's open for people to kind of like build off of, build something a little more creative. Right now, the limitations are this is not the full implementation, so there might be some issues depending on how complex your program is. But yeah, I'd be happy to talk about it with people afterwards and kind of get understanding what the developers are looking for, so that we can enhance the product as we're slowly building out this this AI agent contract. And the link to that website that I just showed you, you can follow that here with this QR code. So what I'm going to do now is I'm going to exit out of here. I'm going to go here to my repo for the AI agent template from Apollon. This is me. I created this publish script. So this is how I'm able to like publish my index.js file here and use my like Apollon API key, my secret here to initialize my storage. Then I define my S3 bucket UUID here. So if I go back to my Apollon place here, yeah. So if I go to storage, I'm using this bucket ID here, and I did it for this one. So the Apollon demo, and I use this bucket UUID to be placed here. And then whenever I compile my script, so I'll run something like npm run build, and it'll build my agent script in this case, and then it'll be in my this folder here. So what's happening here is I create like a file buffer for the index.js file. I then upload that file to Apollon storage, so through the SDK here, and then from there I just wait for the published CID to appear, so that it'll put out an example like AI agent contract deployed at blah blah blah, and make sure to add your secrets. So in the README here, I put all the information here, so you have like how to add secrets in this case, so that whenever you're configuring your agent, you're able to add your secrets here. So you just would put your CID here, your OpenAI API key, and this is how you're able to create a secret. And then this key here, this key is what you will use to define whenever you're defining your URL, so that you can kind of test against this. Whenever you run the npm publish command, so just running this script here, this is kind of an example of what happened. It'll upload one file. File upload is complete, so then it's waiting for the CID to be published. Finally, we get the CID here, and then you'll get AI agent contract deployed at. This link will return an error because you haven't defined your API key, and this code relies on that. And then you would just follow the README to add that, and be able to then open your website and see this here. So, and that key part is what I was talking about right here. And that. So the next part is the Schrodinger's NFT. Mine's still deploying, but essentially what you would have done is you would create like a new Schrodinger's NFT contract. And this is this part of the demo. So I would say test number 2, just to show how this would work. New description. You have Schrodinger's NFT, you have your bucket name, and then you have an NFT collection address. But before I go into this, I would want to, like, if you were to come here right away, you wouldn't see an address. So you would first have to create this. So then you would go to this NFT tab, and you would create a new collection here. And this is like a really easy process. You could already have an NFT, already have it online, but you would just proceed here. You have like the supported ones right now are the Moonbase testnet, the Moonbeam mainnet, and Astar mainnet, where Astar also supports the Substrate and EVM types. So Substrate being like the Ink smart contract version. I'll do Moonbase testnet. It's like select the logo, upload a cover. Just to do a little test, number 2. Here you can choose whether it's generic or nestable. For those that are familiar with Remark NFTs, they mean nestable in this case, so that your NFTs can be nested with NFTs that it owns. So Like in this case, say that you have a body, you have a body NFT and it's nested with like clothes, so that you can put clothes on the body, and it just those NFTs are nested underneath that body in this case. Then it says like use Apollon Gateway for base URI. I'll just go ahead and use that. You can choose like if it's limited or unlimited, how many, revocable, soulbound, royalties address, and then you can add your fees. This one is the drop. So with drop, your collection becomes accessible for visitors to buy NFTs from a certain date onwards. That's interesting. So you just proceed here. You get the information, a little overview. You can then deploy the collection. Just proceed. You have the option to build multiple NFTs at once or one by one. I'll just do the one by one for now. Upload a file, which is, let's do this. ID 0, test number 2, NFT 0. Description. Just one copy. You can add attributes here. So attribute, yeah, you have you could be a boost number, boost percentage, number, date. I'll choose string, and then here, attribute here, and then proceed. Cool. And then you have your like little overview, and you can even like quickly edit. It's very, very nice interface, honestly, like that Apollon's built, and create the NFT. And this should happen pretty quick on the Moonbase testnet. Awesome. So it's deployed. You can go back to the NFT. So we have like the collection UUID. Let's see if we can wait for the contract address to update. So when the contract address updates, then we'll be able to choose in the Schrodinger's NFT piece. So we have the contract address here, still in the status of deploying, but I've already done one previously right before the call. I can show you this. I deployed this on Astar mainnet. You have the base URI here, the collection UUID, the contract address, contract, and we have a transaction here. This transaction was, I believe, like minting. This is like the deployment of the contract. So if we go back here to computing, okay, this is still in the deployment status. You can see like the information here. So you have like the contract address here, the UID, the contract status is still deploying, the NFT collection address that's on Astar that I connected to this Schrodinger's NFT. You can like encrypt the file here, go to storage, check price. If I go back, I'll show you like kind of like the flow of that test number 2. So now we have this here. See if we can, okay, I think this, yeah. So I now have my test number 2 NFT collection I created. So you just click that here and then create the contract, 700. So it's going to be 750 credits. If you do all the really cool token drop task, that you'll be able to get some credits so that you can do this. This is the tasks are a lot of fun, so should definitely try it out. And then you would just like click proceed here, and it should take a little bit of time to initiate the deployment. And then the deployment would be initiated here. I'm gonna stop here and then turn back for questions. See how I can stop sharing and check out.
Yeah, there was one quick question in chat. Let me just quickly see if I can find it. It was from Frank, who was asking, can we give 5 examples that are use cases for AI agent contracts, and just have a clearer picture where it is heading towards.
Wait, which one? Where's the question?
If you open up the chat section, it's from Frank Beaver.
Can I summarize what we've done so far?
There's one from, I think if you scroll up a bit more, it's like, can you give 5 examples that are use cases for AI agents?
Oh, 5 examples. I mean, there's like plenty of examples. Like, for instance, I put one in the docs. It's a very simple example, and it's kind of based off like a blog that I read, creating like a weather agent in this case. So you could have say that you're going to a destination, and you want to know what would be something nice to do in some location, and then it would be able to list you out different tasks that you could do or different places to visit in this case. And it would all you're doing is just asking and providing a location to the agent. Some other more interesting ones would be building intelligent interfaces to Web3 services. So like for indexers, being able to use different queries to do the data retrieval, and then process on that data, and then potentially use that to create the system prompts for your agents, so that whenever you have your agent applications sitting for your clients could go in there, ask a question, and then it would be able to quickly retrieve that data and then bring an answer back to them pretty quickly. Also, another one would be using the indexers to be able to then connect to like a blockchain in this case. So similar to the example I was mentioning in the Phat contract section, being able to bring that off-chain data to like an on-chain blockchain smart contract in this case. Some of these, like all this stuff is like very early. So right now, the use cases that we have enabled are just very, very basic when it comes, and they'll be like more of like single agent, single prompts, some like I said single prompt, but single shot or multi-shot types of examples in this case. But like moving forward, as we move forward, a real example will be agent wars, which is giving the ability for agents for users to deploy agents in this case, and then use keys. So like we have like a default tokenomic that we've built where you would buy a key for an agent so that you can interact with them, and then it almost like creates like this DAO where if you have a key, you also have like a way to govern this agent in the future, and be able to make upgrades to the agent and kind of own it. But as people buy keys, you also earn profits as more people buy keys for your agent and utilize your agent. And then you can also use those keys as a way to like offer subscriptions for users and different ways to create like these intelligent applications or AI agents to be able to like really like monetize the work that you've built. Because right now it's really hard to do that in today's like AI agent like development stack. There's not a lot of ways to easily monetize your products in this case when people use it, if it's really good. How are those use cases different from an Oracle chain link? How is it different? I mean, depends on what you're building. The use cases are actually pretty, like the Phat contract use cases from the past when it comes to like using the off-chain rollup to be able to communicate with on-chain smart contracts in this case. They kind of operate similarly to like an Oracle in this case. it's just like a customizable Oracle so that you could customize your contracts and be able to update your business logic. It's kind of like the Chainlink functions in a sense too as well. Or like I think Gelato has like the Web3 functions as well. But with the AI agent contract, it's a lot different because this is running in a long living virtual machine. So you have like 30 seconds or more time of computation. And in this case, you're also able to serve through a gateway, so you can make get and post requests. Some of like those examples, some of those examples I could see, like say like you were to want, like if any of y'all are like familiar with frames that are on Farcaster, you can use this AI agent contract to serve as the backend, and then you would just create a frame that is making the get and post request to your agent script, so that you could then have like an agent running in a frame, be able to communicate with the agent and have information returned back, and you could create also your applications in this case. So like say that for like agent wars, that could be a possibility as well. See is why I need the blockchain for that, just elaborate. I love the concept, but doesn't click. So AI agent governed by chain consensus. Slowly I get there. Why you need the blockchain. So the blockchain is really used as almost like a regulator to the AI agent, and being able to ensure that this agent has like access control features built in, but also you have to buy the key. So that then creates like a way for the agent developers to profit, but also the people that are key owners, they also have a way to profit as the agent gets more popular. In this case, that would be like the on-chain blockchain, like the on-chain smart contract piece of this for the blockchain. On the other side, you also have, you don't want that agent script running in some server that may like leak some secrets in this case. So being able to utilize Phala as the backend for that, where it's executing in a trusted execution environment, you can like ensure like privacy and security by default in this case, so that your secrets aren't leaked, and you can ensure that the execution of your agent scripts are verifiable in this case. Do you want to come on? Oh,
yeah, I'm going to add Patrick on stage once we're done with questions. Patrick is from Appian, and he would love to address also the audience as well. So there's a new question from Matthias.
Okay. What's the cost of running an agent? Any cost metrics out there? So for instance, right now the cost is it would be you buying an API key for whichever LLM API that you use. But in this case, like OpenAI, you'd have to have like to buy that subscription. But for now, the fee would be that, the subscription, also publishing to IPFS. But here you have Apple on, so you can do that for free. For now, it's going to be free. In the future, we'll figure out a way to charge. But since this is not we haven't fully implemented our AI agent contract stack, there's not going to be a fee until something makes sense in the future.
Makes a lot of sense. Any other questions by the audience? In the meantime, I will quickly invite Patrick on stage. Hey, Patrick.
Hey, guys. Do you hear me?
Yes, we can, loud and clear.
Nice. Yeah, so thank you, Austin, for tuning me in. And yeah, Joshua, thank you for joining this workshop, presenting here, especially for sharing the Appian platform. I saw that there was quite some interest in the chat. So as Yasin also wrote in the chat, on the 22nd of May, Nino, our product owner, will be having overview of the Appian platform workshop. So yeah, I forgot to introduce myself. I'm the growth manager at Epsilon and also the initiator of the Build and Polkadot event. So the thing is that we designed this event kind of like in few stages. First, with workshops, but we wanted to, so as we are a development platform, we are integrating Polkadot parachains on backend, and we wanted to have the parachains representatives, how to say, like, present first what they do, so what each of the parachains does, and then wrap it up together, like into how this is connected within the Epsilon platform. So yeah, one thing also, Joshua mentioned credits. So in case if you're gonna register on our platform via the register link that it's in the hacker pack, so this link, it has like a referral code, and you're gonna get additional, I'm not sure if 10,000 credits or 5,000, something like that. So you're gonna get some extra juice to play around on the platform. So this is basically it. Yeah, don't forget to join us at the bounty, which will start after Epsilon's presentation. And yeah, we are really looking forward to what you guys will build. Like, considering the engagement on these workshops, I'm pretty sure that there will be some interesting stuff built here. So yeah, thumbs up to everyone.
Thank you, Patrick, for joining. There's a final question coming in from Matthias. It's any potential integration with Arweave for the storage contract. The question is obviously aimed for Joshua.
Arweave, right now we don't support it unless you're using like some other service that supports like Arweave additionally to so you would use Arweave, like I think Foreverland does this, but they have you can save the file to Arweave and then have like an IPFS link so that whenever you're accessing the file, it doesn't have that long latency of retrieving the Arweave file. That would be one thing, but maybe Apollon will support Arweave in the future. I would think maybe that would be something interesting there.
Yeah. So we don't support that. We don't support Airweave at the moment. I cannot promise anything, but what should I say? If there will be a need for it, it definitely gives us an incentive to integrate Airweave as well. So yeah, I see that there is a question. What's the best place to ask questions? I would say our Discord. Our Discord is like the best place to go. Also, the Encode team has like a dedicated Discord channel, so you can ask there directly, and our team will get to it.
And I'm also always available, so feel free to DM me with any questions, and I will forward to the Epsilon team, and they will then handle these accordingly. So, perfect. Any closing words, both Joshua and Patrick?
Yeah, nothing special from my end. I'm really looking forward to the next workshops that are coming, but more than that, I'm really looking forward to the building phase. So yeah, thanks you all for joining here.
Next week we will have a workshop from Andres, who is going to be from Qt Protocol, which is going to be about Qt Protocol and DIDs in general. It's going to be a really interesting workshop. So as always, feel free to join in. I'll make sure to post everyone a lot of reminders in the lead up. And for those of you that attended today or think they missed something, don't worry about it. Workshops are being recorded, and all the materials, including the slides, will be added to the hacker pack, which I linked, and I will make sure to link once again, just so everyone has access to it. This is the hacker pack. Everything that you might ever be in need of is in it. Description of the bounty, what you might need to build for it, as well as some basic documentation lists, and all kinds of materials that you can utilize, and make sure that you submit something of value by the end of it. But yeah, that is all. Thank you, Joshua, and thank you, Patrick, for tuning in as well. And thank you to everyone in the audience for your amazing questions and the engagement. Love to see it, and looking forward to see you next week as well.
Awesome.
See you all.
Everybody.
Thank you. Bye-bye.
Bye all.